right. All right. So I'm going to try to solve this problem, which come from a tutorial exercise that one of my friends sent me. So I'm going to start by reading the question. The length of a rectangle is increasing at a rate of 6 centimeters per second, and its width is increasing at a rate of 4 centimeters per second. When the length is 14 centimeters and the width is 4 centimeters, how fast is the area of the rectangle increasing? So here we want to find how fast the area of the rectangle is increasing. So when I think about how fast something is changing, I think about the rate of change. And the rate of change, basically, to my knowledge, is the slope of a point, the slope of a line at a particular point. So that's one of the first thing that came to my mind. What came to my mind was slope. The other thing that came to my mind was the was to find the relationship between the rectangle, the area of the rectangle, and the rate at which the width and the length are changing. So to start, I'm going to go ahead and write the formula for the area of a rectangle. I know that the area of the rectangle is the length times the width. So with this in mind, I know that if A has to change, the length has to change, and the width have to change. Here, what is very important to look at is the relationship between the area, the length, and the width. And in terms of function, we'll think that the length is changing at a particular rate, and the width is also changing at a particular rate. But at a certain point where the length is 14 centimeters and the width is 4 centimeters, we have a given rate of change. So now, what I'm going to do is to try to find the derivative of A with respect to time and the relationship that it has with the length and the width as are both changing. So what I'm trying to find is dA dt as the length is changing. I'm going to put changing, and the width is changing at a given point, So how do I do that? I need to find the derivative of this whole thing here. So I know that since I'm multiplying two functions, I need to use the product rule. And for that, I'm going to say that L, the length, is U, and the width is V. So I'm going to use the product rule. So U prime times V plus V prime times U. So now I have U prime is dL dt, so for my handwriting, multiplied by V, which is my width, plus dW dt times U, which is L, my length. And all of this is equal to dA dt. Right now, another important thing to notice here is that they gave us everything that we need to know. They told us that the length of the rectangle is increasing at the rate of 6 centimeters. So my dL dt is equal to 6 centimeters per second. And its width is increasing at a rate of 4 centimeters per second. So dW dt is equal to 4 centimeters per second. And they say that when they want to find what is the change happening to the area at the point where the length is 14, so when L is 14, and the width is 4, right? So I have all of this here, which I'm going to copy. And come in and paste it down here next to my formula. So I know that now I have dL dt, I have width, I have dW dt, and I have my length. I can just put all of these into my equation to find what dA dt is. So this gives me dL dt is 6 multiplied by the width, which is 4, plus dW is 4, and the length is 14. So this gives me 12 times 2 gives me 24, and this gives me 28 14 times, so this gives me 56, if I'm right. Let me just look at my calculator if that is right. So 14 times 4 is 56, and 6 times 4 is 24, and when I add them together, this gives me 80. So the area is changing at a rate of 80 centimeters square per second, and this is my final answer. I hope this was helpful. Thank you so much.